So hi, welcome guys to the practice session 3 of the chapter that we are currently doing, which is our chapter 7, triangles and its properties. You guys remember in our previous sessions, we have already discussed some major properties of the triangles, types of the triangles and congruency criteria that were used to call two pair of triangles congruent, and you guys already should remember what congruency is and what similarity is. So I had deeply discussed both of the topics so that you might not be having any troubles. If you are just watching from your class 10 for the revision, if you are attempting a chapter triangles chapter in your class and you want to get your basics clear regarding the congruency and similarity, because you will be having that topic there, you will be having specifically a topic of similarity, but in this case in your class 9 you already have the topic of congruency. So this will come handy if you are preparing for class 10, if you are just wanting to get your basics clear, you want to distinguish between both the terms that have already been discussed in the earlier sessions. So I'm gonna do what? I'm gonna pick up where we had left in the earlier session. You guys remember where we had left? We had completed our exercise, not chapter actually, sum 3 of exercise 7.2, right? We had completed till then and I had wrapped things up there. So I will be doing what? I will be picking up from there. We will be having the sum number 4. We will be following up with that sum, and then we will be moving towards the major concept in this session, which is your right angle, hypotenuse and side. This is very important congruency criteria when it comes to your right angle triangles. So we will be discussing this along with some properties in order to get various sums or various triangles congruent without even applying or just proving some things without even applying the congruencies, because there will be some concepts that will directly be applying here and we will be getting the things that we want without even going towards the congruency case. But remember, you have to understand, you have to make proper notes of this chapter, and for that you can just log on to our website, you can get yourself registered. We have lots of notes, revision notes, practice sums, each and everything is well structured there. You can just download the notes if you are too lazy or you don't want to write them down in your own handwriting. So we have prepared the notes there, you can just get them and you can just revise whenever you want. You can have on-demand videos there, recorded sessions there. So just get yourself registered there. Now I'm going to do what? I'm going to start with the video. And before we get to the point, I'm going to do what? I'm going to have some revision portion right here. So for revision, I'm going to revise each and everything that we have learned up till now. So what were the major criteria? You guys remember you had side criteria, side angle side criteria, and you had angle side angle criteria, and angle side criteria, which was the implication of angle side angle. There I had specifically told you that there is nothing like side angle, and I had also explained it to you that there was nothing like angle criteria. Although three sides can be a valid congruency criteria, but three angles cannot be. I have explained them deeply in depth in our earlier session. I guess that was the session 1, right, which was held on your I guess 30th May, right? 31st May. So we had discussed each and everything in deep there. So if you are having any doubt, just you can go back to the playlist and get that video, or you can just log on to website like I told you we have there. Now after that we had understood the concept of our isosceles triangle. So that was the major thing that we had to understand in this. So what was an isosceles triangle? Isosceles triangle was that triangle in which the base two angles were equal and the sides were equal as well. So the triangle in which a pair of adjacent sides are equal and angle opposite to the equal sides are equal, that figure will be an isosceles triangle. So you guys already remember we had proved this one, that if the sides are equal then the lines will be then the angles will be equal to, and when the base angles are equal or the opposite angles are equal, then the adjacent sides will be equal to. So we had proved each and everything. You can take your bisectors and you can prove that on your own. You can just rewind the video and watch it again. We have already done this one, so I'm not going to start proving this one again. If you have any doubt, you can just go back to the video. But like I've told you, we will be following up with the sums. So without wasting any more time, let's start with the video. So this is our sum number 4 that was actually left. So ABC is a triangle in which altitudes BE and CF, this BE and CF, to the sides AB and AC are equal. Don't get me wrong here, or don't get the question wrong here. It tells you that the altitudes BE and CF to the sides AC and AB are equal. They have written it quite cleverly, but this is clear. just to confuse you guys, they have written it like this, but you guys see, you are intelligent. You guys will be assuming this one. Just remember this. They are talking about your BE and CF, not AC and AB. Don't get it wrong here. AB and AC are not equal. They have clearly stated in the second part too that AB and AC have to be proven equal. They are not equal, although the altitudes are equal themselves. That means BE and CF are equal. AC and AB, we have to prove them. And just one more thing, we have been given that the lines are perpendicular, right? They are altitudes, so altitudes are obviously 90-degree angles. Now you have to do what? You have to prove triangle ABE is congruent to triangle ACF. ABE, ACF both have to be congruent. Now this is quite easy. Just write given. How you're going to attempt this one? I can see if I just look at these figures in triangle BEA, that means this triangle right here. Right. If you look at this one and if you look at this triangle CAF. Now in both of the triangles, one thing is clear, one thing should be clear to you, that this angle A is common to both triangles, right? And these two are 90 themselves, and we have a pair of sides equal as well. Then using your angle congruency criterion, we can say triangle I'm just getting confused here. BAE is congruent to triangle CAF, right? If they are congruent, you can just name them accordingly. You can name this ABE or BAE. Then remember, it has to be CAF if you are naming it like this. If you are naming it like this, BAE, then other has to be named like this, CAF. But choice is yours. You can name it like this. But remember, naming is important. That was the major thing that we had discussed in our session 1. Remember, you cannot manipulate with the names. So this will be it. I'm going to erase this one. So you guys understand the idea. We are going to write solution now. So what should be the solution? Let's see. For solution, firstly we have to write given. So what is given to us? Let's write it. We have been given that BE and CF are perpendicular to AB and to AC and AB. Let's write them accordingly so that you don't get confused here. So BE is perpendicular to AC and CF is perpendicular to AB respectively. Okay, I hope you guys understand this. So yeah, now then we have been given that this implies angle BEA should be same as angle CFA should be same as 90 degrees because the lines are perpendicular, because they are altitudes, right? Also, I have been given that BE and CF both are equal. Now what do we have to prove? Required to prove is, in first part we have to prove that triangle ABE should be congruent to triangle ACF, and then we have to prove that AB is equal to AC. So in second part we have to prove that AB line segment should be equal to AC. So these are the things that we have to prove, and you have to write each and everything accordingly. You have to follow this process. You have to write given statements, you have to write required to proofs. If you are doing some constructions, then you have to write those constructions as well. You cannot skip any method, you cannot skip the steps. So I'm gonna erase this one. So now towards the solution. So actual solution now. So in triangle ABE and triangle ACF, I can see BE is equal to CF. Okay, I can see angle BAC is equal to angle CAF. I'm going to write the reasons, just give me a second. And I can see angle BEA is equal to angle CFA. Now you guys see, this is already given. This is common. You guys see angle A is common to both triangles, and this is 90 each, right? Both of them are 90. So you guys see, if you use this, you have a side, you have an angle, you have an angle. So by angle side criteria, triangles ABE and ACF are congruent, right? Triangle ABE and triangle ACF congruent. Therefore, I can say AB is equal to AC because both of them are the part of the triangle, and they will be CPCT. That means congruent part of congruent triangles. So you guys remember this CPCT, right? It was the ability, once you have proven a pair of triangles congruent, then you have the special ability, you can prove the remaining sides to be congruent. You guys remember this? I had taken this example also. We had two rectangles, right? Such that their dimensions, let's say, let me just erase this one. Let's just put it like this. So we had these two rectangles, right? Let's say this was 2 centimeter, this was 90, and this was 90. And you guys see, I knew this was 90, this was 90, and this was 2 centimeter as well. So you guys see, what can you tell about the other side? Since the figures were congruent, then you could say this side will be same as this one, this angle will be same as that one, and this angle will be same as that one. Because you guys see the figures are congruent, then the remaining values which are left, or remaining angles or sides which are left, they can be proven congruent using congruent part of congruent triangles. Because the triangles are congruent, then the remaining portions have to be congruent too. So that is the whole point of this CPCT. I hope you guys remember this and you don't have any doubt in this, right? Now let's move forward and see with the fifth question. We have this one. Now this is quite easy. There are various methods to move around this question. One of those methods is what? Firstly, let's read the question, then I'll explain the methods. So ABC and DBC are the two isosceles triangles. Remember, they are isosceles triangle. They are isosceles triangles. That means their adjacent sides will be equal and their opposite angles will be equal. That means pair of these two sides, AB will be same as AC. These are markings here. And DB will be same as DC. These are the markings here. And angle ABC, which is this one, will be same as angle ACB, which is this one. Similarly, angle DBC, which is this one, and angle DCB, which is this one, these two are equal themselves and these two are equals to themselves. So we have to show that angle ABD, that means this complete angle, will be same as angle ACD, that means this complete. Now what happens is, there are various ways to move around this question. The popular method should be what? Popular method should be just join AD. Do what? Just join AD. Okay. Now guys, see, we have two triangles right here, ABD and ACD. Now guys, see, AB is equal to AC, BD is equal to CD, and this AD is common. So you guys see, both of the triangles are congruent, and you can say what? Angle ABD, which is this one, is congruent to, is similar to triangle, is equal to angle ACD, which is this one, right? You can use the term congruent also, because that means exactly the same, that means inequality. So angle ABD is equal to angle ACD, or you can say triangle ABD is congruent to triangle ACD. Then using CPCT, you can easily prove that one. But that is a lengthy method and examiners don't find that method quite appealing. The simplest way you can do is with the help of your isosceles angle property. Now guys, remember the triangles are isosceles, right? Isosceles triangle property states that if two sides are equal, then the angles opposite to the equal sides are also equal. That means this is same as that one, like I've told you. Similarly, this is same as that one. And you guys should be remembering that if 1 is equal to 1 and if I add 2 to both sides, then 3 should be equal to 3, obviously. You guys see, if angle B is same as angle C, this angle ABC and angle ACB both are equal, and angle DBC and DCB both are equal, then I am adding equality to equality, then answer whole will be equal. So angle ABD will turn out to be equal to angle ACD. So that is the approach that I will be using, but that does not matter. I will be attempting with both methods. So see, if I erase this one, so firstly method 1. So for this, I'm going to do some constructions. So in given, you have to write each and everything that has been mentioned here. So you can write this on your own. ABC and DBC are two isosceles triangles. So I'm going to write it like this. Angle ABC is equal to angle ACB. Angle DBC is equal to angle DCB. Also, AB is equal to AC and DB is equal to DC. So these are the things that have been given to me. I will be doing some construction. I will be doing what? Join A to D. But that means join AD. Now guys, see, if I just join this one, so this will be the figure that is completed. Now in triangle, now you can write required to proof on your own, so I'm not going to write it again. I'm just going to do what? I'm just going to do the solution. So in triangle ABD, you have what? I can see AB is the, and let's write it completely. In triangle ABD and triangle ACD, I can see AB, this side is same as AC. I can see BD same as CD, and I can see AD which is same as AD, because this is given, this is given, this is common. So side, 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 using side congruency criteria. Triangle ABD is congruent to triangle ACD, and you have to do what? You have to prove that ABD is equal to ACD angle. So angle ACD is equal to angle ABD using CPCT, right? That was the method 1. You guys see this was quite lengthy. The other method is quite simpler, so I'm going to erase this one and let's see the method 2. So method 2 now. This is quite easy. For this you should be remembering your isosceles triangle property. So you guys see angles opposite to equal sides are equal, right? So angles opposite to equal sides are equal. So this implies angle ABC is equal to angle ACB, since AB is equal to AC. Mark this one your first. And angle DBC is equal to angle DCB, since DB is equal to DC. Right? Mark this your second. Now do what? Add 1 and 2. So if you add 1 and 2, angle ABC, ABC which is this one, DBC which is this one, adding both of these two, you will be getting what? Angle ABD, right? And angle ACB which is this one, and angle DCB which is this one, adding these two, you will be getting what? You will be getting angle ACD. So this implies angle ABD is equal to angle ACD, and hence proved. So you guys see this was quite easy. You just did what? 3 steps, I guess. You took 3 steps and you got the answer that you had to prove. So that's why method 2 is quite easy and appealing, because that will be showing how knowledgeable guys you are. So you should be remembering this property. You should be using this one quite often. If you guys can use this in any sum where this is applicable, then you should use this one rather than going for your congruency and everything. Although they are correct, each and everything is proven using congruency, but since we already know this theorem, so we can write this one, but you can do with that method also. So now let's see what do we have in the 6th sum. So it is this one. Triangle ABC is an isosceles triangle. See, ABC is an isosceles triangle in which AB is equal to AC. AB is equal to AC. Side BA is produced to D. BA is produced to D such that AD, this is same as AB. Now we have to show that BCD is a right angle triangle. We have to show this, that BCD, this angle right here, this is 90. Now guys see, this is quite easy. How we are going to do this one? See, I know ABC is an isosceles triangle. So you guys see, this will be what? This angle will be equal to this one. Angle opposite to equal sides are equal. And I know this angle right here, this angle will be same as that one, right? So you guys see, if this is the case, if sum of, see, what happens is this angle is equal to this one, this angle is equal to that one. So I know if I add these two, I will be getting this complete angle C. Let me just use the namings here so you guys will be understanding this. Let's mark this one first, this one second, this one third, and that one fourth. Now you guys see, I know if I use the theorem, isosceles triangle theorem, I know angle 1 is equal to angle 2 and angle 2 is angle 3 is equal to angle 4, right? And I know if I just do what? If I just write them like this, angle 2 plus angle 3, that will be what? That will be complete angle C. And I know angle 1 plus angle C plus angle 4, that will be what? That will be 180, right? Angle 1, angle 3, sorry, let's just call this angle C, not angle 3. Let's call this one angle C. Okay. So angle 1, this angle C, this complete, and this angle 4. Sum of those will be 180, angle sum property. I know angle C itself is what? 2 is same as 1, 3 is same as 4. So can I write it like this? Angle 1 plus angle 2 plus angle 3 plus angle 4 equals to 180. Now angle 1 and angle 2 both are same. So can I write it like this? Angle 2 plus angle 2. And I know angle 3 plus angle 4 both are same as well. So angle 3 plus angle 4, or you can say angle 3 plus angle 3, right? Both are equal. So angle 3 plus angle 3, which is equal to what? Which is equal to 180. So you guys see, 2 of angle 2 plus 2 of angle 3 equals to 180. So angle 2 plus angle 3, that should be 90. And angle 2 plus angle 3 was what? It was angle C. So angle C is what? It is 90. And you can say angle BCD is 90 degrees. So this is how you are going to prove this one. I hope you guys understand this. If you want me to repeat this again, I'm going to do the solution again with the whole method. So this was what we had to do in this. Now let's see the entire process of this one. So I'm going to erase this. So I had been given each and everything. You can write this one down. So I'm just going to come to the solution now. So solution, I know in triangle ABC, AB is equal to AC. Therefore, angle ABC is equal to angle ACB. Mark this one first. Or you can write this one as theorem 1. You can write that also. Similarly, in triangle ACD, which is this one, I know AC is equal to AD. Therefore, angle ACD is equal to angle ADC. Mark this one a second using same theorem. Right? Now do what? Add all these. Angle ABC plus angle ACB plus angle ACD plus angle ADC. That should be 180. Sum of all angles. This plus this plus this plus this. ASP of triangle BDC. Okay. That will be the case, right? So I know ABC is same as ACB. So can I write it like this? Angle ACB plus angle ACB. And I know ACD is same as ADC. So can I write it like this? Angle ACD plus angle ACD. That should be 180. Now you guys see twice of ACB, twice of ACD equals to 180. So angle ACB plus angle ACD, that will be what? That will be 90. Now ACB and ACD, that is what? That is actually BCD, which should be 90. And this is what we had to prove. I hope you don't have any doubt on this, so because that will be the solution of this question. So BCD will be what? It will be 90 degrees. And this is how you are going to prove this one. I hope you get the point here, what we have to do. Now let's move forward and see what do we have now. So in a seventh sum, see, this is very important and this is very easy too. ABC is a right angle triangle in which angle A is 90 and AB is equal to AC. Find angle A and angle C. Sorry, angle B and angle C. Now guys, see, you have been given a right angle triangle. Let's say this is the right angle triangle right here. Okay. And angle A is 90. So this must be angle A, which should be 90. This is angle B, or let's just call this one the vertex B, and angle should be on the inside. So this is B and that is C. I have been given that AB is equal to AC. Now we have to find this angle B and angle C. Now guys, see, these angles will be equal, right? Because angles opposite to equal sides are equal. AB is equal to AC. If AB is equal to AC, therefore this implies angle B is equal to angle C. So simply you can do this. Angle A plus angle B plus angle C equals to 180. Angle sum property. Angle B and angle C are equal. So can I write it like this? Twice of angle B equals to 180 minus angle A, which should be 90. So angle B will be what? It will be 90 as well. So actually twice of angle B will be 90 as well. So B will be what? 90 divided by 2. You can say 45 degrees. So angle B is 45 degrees and angle C is 45 degrees. So I hope you guys understand this. So remember, these kind of figures are your isosceles right angle triangle. Remember, this is isosceles rat, or you can say right angle triangle. In isosceles right angle triangle, two of the arms will be equal, adjacent arms, and third will be not equal, right? Remember, there is no such thing as an equilateral right angle triangle. That cannot happen because sum of two sides has to be greater than the third one. Always remember this condition. So this will be the case here. And we have the question based on your equilateral triangle also. We have to prove that why in an equilateral triangle each angle is 60 degrees. So remember, here I will be proving that why there is no such thing as an equilateral right angle triangle. Now for this, I'm going to do what? I'm going to draw an equilateral triangle. Okay. Now the condition for an equilateral triangle is what you guys will be telling me. So tell me in the comments. Let me just erase this and draw it neatly. So let's say this is an equilateral triangle ABC. Now I hope you guys will be answering me this one. So I know in an equilateral triangle all of the three sides are equal. So AB is equal to AC is equal to BC. I know in equilateral triangle AB is equal to BC is equal to CA. or you can say AB is equal to AC is equal to BC. Choice is yours, you can name this accordingly. If this is the case, if I assume, firstly, if I only assume AB is equal to BC, AB and BC are equal, then these two angles have to be equal. That means angle BCA must be equal to angle BAC, right? Using theorem 2. Also, if BC is equal to CA, if this BC is equal to CA, then I can say these two angles should be equal. That means angle CBA has to be equal to angle CAB, using same theorem 2. Now guys, see, BCA is equal to BAC, CBA is equal to CAB. Both of the angles are equal, therefore I can say angle ABC is equal to angle BCA is equal to angle ACB. All three angles are equal. Let's say they are x degrees. So x plus x plus x equals to 180. Angle sum property of triangle. So 3x is equal to 180 degrees. X will be what? X will be 60 degrees. So you guys see, each of the angle in an equilateral triangle is always of 60 degrees. I hope you guys understand this, and you should not be having any doubt regarding why there is no such thing as an equilateral right angle triangle, because that is the reason each and every side is equal. Then each and every angle has to be equal. Considering you are taking two sides at a given time, then angle opposite to the equal sides are equal. You can use that theorem and you can easily prove that each of the angles will be 60 degrees. I hope you guys don't have any doubt in this. Now let's move forward and see what do we have now. So we are going to begin with this now. This is theorem 7.5. This is very important theorem. This is RHS congruency rule. Now what is an RHS congruency rule? RHS stands for, you guessed it, right angle, hypotenuse and side. Yeah, that's the case. So remember, this congruency rule will be applicable in only the pair of right angle triangles. So if you have a pair of right angle triangles, then the properties that you should be using to prove them congruent, considering their hypotenuse and sides are equal, then that congruency rule will be right angle hypotenuse side. But if the hypotenuse is not equal, then you can use angle side angle or side angle side. That will totally be depending upon the nature of the question that has been given to you. Now what this theorem states, it states that if in two right angles the hypotenuse and one of the sides of the triangle are equal, that means if in two right angle triangles, let's say I have two right angle triangles A, B, C, such that right angle is on B, at B actually, and let's say I have another figure which is DEF. Let's say it is like this, DEF, such that right angle is at E. So if you have been given that one side and one hypotenuse, let's say BC is equal to BC is equal to FE and AC is equal to DF. Remember, this is DF. Then the congruency rule that you should be using is your right angle hypotenuse side, considering 90 same as 90, hypotenuse AC is same as DF, and base BC is equal to EF. So if let me just write it properly. If AC is equal to DF and if BC is equal to EF, and finally angle ABC is equal to angle DEF, which is 90 in this case, they are also given, then the property will be like this. This is your right angle, this is your hypotenuse, and that will be side. So triangle ABC will be congruent to triangle DEF using right angle hypotenuse side congruency criterion. So this is a very important congruency criteria, congruency rule, because you will be using this one while you are dealing with your right angles and your right angle triangles. So let's move forward and see what do we have with us. So we have this example 7 with us. This is very important. So we have this question. Remember, we have this. Now this figure should be looking familiar to you. You guys will be calling this one as your kite or your rhombus. That concept, the difference between kite and rhombus, has, I guess, yeah, we haven't been discussed regarding this. We haven't discussed this. This will be a major concept while you are in your chapter quadrilateral. Remember, they are actually, the thing is, people usually mistake them to be the same things. They probably assume that kite and rhombus is the same thing, but actually kite is a totally different type of a quadrilateral and rhombus is a totally different quadrilateral. See, there will be a fine difference between those. I will be explaining those. So till we get to the chapter 8, just bear with me. You can just call this one as your rhombus or your kite, it does not matter. But while we are on chapter 8, I will be specifically telling you why this can be a rhombus or cannot be a kite or whatever that is. So I will be explaining that, but in this case this can be called a kite, but this cannot be called a rhombus. The major thing you will be discussing, you will be having discussed in chapter 8, but for now let's just come back to the question. So we have this one. AB is a line segment. P and Q are the points on the opposite sides of AB. AB is a line segment, P and Q are the opposite sides of AB, and such that each of them is equidistant from point A and B. That means P and Q are equidistant from A and B. That means this AP is same as PB, this AQ is same as BQ. Show that line PQ is the bisector of AB. We have to show that this PQ is bisecting AB. That means AC should be equal to BC. We have to prove this one. Now this is quite easy and quite interesting. Now guys, see, required to prove is AC should be equal to BC. This we have to prove. Now coming to the solution. Now you guys see, in triangle APQ and triangle BPQ, APQ, BPQ. Now you guys see, AP is equal to BP, AP is equal to BP, and you can see AQ is equal to BQ. This is the same as that one, and you can see PQ is equal to PQ, which is common, right? This is given, this is also given, and this is common. So you guys see, side, triangle APQ is congruent to triangle BPQ, right? So you guys can easily prove now. What you can prove in this, you have to make sure that both of them are equal. So what can you do with this? I can use right angle hypotenuse side criteria, but for that I somehow need to have something like this. For this I need to consider these two triangles, right? In order to prove AC and AB equal, I need to have at least these two triangles, so we can take these two. Actually, we can take these two in order to prove them, or these two. So for this, I'm going to do what? I'm going to make sure that these two angles are equal. So you guys see, these are already given to me that are equal. If these two angles somehow are equal and this side is common, so side angle side, triangle APC will be congruent to BPC. And using CPCT, you can say what? AC is equal to BC. And you have to show that it is perpendicular bisector. So this angle has to be 92. So you can say ACP is equal to BCP. Both of the angles will be equal, and you can use your linear pair to solve them. So I hope till here you guys understand this. So what I'm going to do now, I'm going to make sure that angle APC is equal to, or you can say APQ is equal to angle BPQ CPC2. Okay, these two angles are proven equal. Now I'm going to erase this one. So in triangle APC now and triangle BPC now, you guys see, AP is equal to BP, already given. This is given, right? And I know angle APC is equal to angle BPC. This is proven, right? And I know PC is equal to PC. That is common. If you wanted to take the bottom two triangles, then you would have proven them equal. You could have proved AQC is equal to BQC. That will be the same case. But in that case, you will be taking triangle AQC and BQC. So that does not matter which type of triangles are you going to take. You can take either of those, but you have to make sure that you are taking them correctly. So you guys see, side angle side, triangles APC and BPC, both are what? Both are congruent, and by which? By side angle side criteria. And you can say angle ACP is equal to angle BCP, CPCT. Also you can say AC is equal to BC, CPCT. Now guys, see, if both of these two angles are equal, then one thing is left here. If AB is a line segment then you can say what? Angle ACP should be equal to angle BCP, that is already given. Therefore, angle ACP plus angle BCP should be 180 and both of them are equal. So, angle ACP will be what? 180 divided by twice of ACP, that will be what? That will be 90. So, this is 90, this is 90 and these two are equal. So, you guys have proved that PQ is perpendicular bisector of AB and it bisects AB. PQ is perpendicular to AB and it bisects AB too. So I hope you guys understand this and you don't have any doubt in this. Now let's move forward and see what do we have now. So we have this example 8 with us. P is a point equidistant from two lines L and M. P is a point which is equidistant from two lines L and M. You guys see this is same as that one. Show that line AP bisects the angle between them. We have to prove that this AP, this line bisects angle A into two equal parts. Now this is an important question. Now guys, see in figure it has been given to you that they are P is actually BP and BC are what? BP and PC are perpendicular to line AL and AM. Now guys, see if this is 90, this is equal, then this side should be common. So if you look at this, we have two triangles right here where APB is acting like this is 90, and we have another triangle APC where this is 90. You guys see 90 and 90, this side is same as that one. Considering this is actually not that one, we have to take this, sorry, this side is not equal, actually the equal side is this. BP is equal to CP, and you guys see I can see AP is common in both. So right angle, hypotenuse and side. Using RHS congruency criteria, you can say both of the triangles are congruent, and you have to prove that these two angles are equal. That means they are bisected. So you can easily prove them using a CPCT. So I'm going to erase this one and see what do we have now. So in triangle APB and triangle ACP, right? You guys see in these two triangles, I can see BP is equal to CP, angle PBA is equal to angle PCA, 90 each, and that has been given, and I know AP is equal to AP, which is common, right? So you guys see, actually we have to name them accordingly. APB, this should be APC, right? So you guys see right angle, hypotenuse, side. So using RHS, triangle APB is congruent to triangle APC, and you can easily say now angle BAP equals to angle CAP CPCT, and you can say what? Therefore AP bisects angle. So I hope you guys understand this and you don't have any doubt in this. So let's move forward and start with the very first sum of our exercise now, because let's just complete how many sums we can in this sitting now. Then we will be moving to our session 4. I'll be seeing you tomorrow. Let's just complete this sum and we'll have the further ones and the remaining portion in the next session. So guys, see we have this one. Triangle ABC and DBC are the two isosceles triangles on the same base BC and the vertex AD. You guys see ABC and DBC. These two triangles are on the same base and vertices AD are on the same side. You guys see they are on the same side of BC. If AD is extended to intersect BC at P, if AD has been extended to intersect BC at P, we have to show that triangle ABD, which is this one, ABD, is congruent to ACD, which is this one. We have to prove them equal. Then we have to do what? Then we have to prove ABP, this whole is congruent to triangle ACP, this whole. Then we have to prove that does AP bisect angle A as well as angle D. We have to prove that these two have to be equal and these two have to be equal. And we have to prove that AP is the perpendicular bisector of BC. And lastly, we have to prove that this BP should be same as CP and this angle DPB and DPC both have to be 90 degrees each. So these are the things that we have to do in this question. Although this question is quite lengthy, but this is very important and this is very easy too. You have to just follow the steps right here. You have to prove each and everything in an order. Then you will be having the next thing proven. So before we get to the point, let me just again tell you, ABC and DBC are isosceles triangles. So you guys know the property of isosceles triangles. What will that be? See, you guys know in isosceles triangles, a pair of adjacent sides are equal. So these two sides will be equal. Similarly, these two will be equal, right? If two sides are equal, then their base angles have to be equal. So this angle B will be same as angle C, and this angle DBC will be same as DCB, right? And what else? Can you see anything else? Is there anything else? Now you guys see, we don't have anything else apart from this one, although we know this. If I just erase this, if you look at this one, they are on the same base, right? They are on the same base. If I just assume this triangle first, if I just assume this, let me just erase this. If I just pick this one, if I just take this triangle and take that triangle, I can see if I take ABP and ACP, I can see AB is same as AC, right? One more thing I can see, angle ABC, this is same as angle ACB, right? What else can you see with this? Can you see anything else? If you look at this one, you guys will be telling me that, sir, we should take this AP as common, right? But that cannot happen. See, side, side, and a total different angle. This cannot be the property. So if you somehow try to choose this valid reason first, then you won't be able to solve that one. For this particular thing, you have to follow this order. See, I know both of the triangles are equilateral, right? So AB is equal to AC and DB is equal to DC, right? And I can see this is common, pretty straightforward. Side angle side, both of the triangles are congruent. Then I can say this angle is equal to that one. Or you can do what? You can better take these two equal, right? Because we don't have to prove that BD and DC, or you can say DB and DC are bisecting angle B and D, that B and C, we don't have to prove that, but we do have to prove that DA, or you can say AD, is bisecting angle A, and AP is bisecting angle D also, and the base, it is a perpendicular bisector. So we have to prove these two things. We don't have to go anywhere near these two angles. So I won't be going there, but let's just write the solution now. So solution, you guys know, given is what? Given things are ABC and triangle DBC are isosceles triangles. Therefore, I can say therefore I can say AB is equal to AC and DB is equal to DC. So in triangle ABD and triangle ACD, okay, now guys see, AB is equal to AC, DB is equal to DC, and I can see AD is equal to AD. These are given and this is common. So you guys see, using side criteria, triangle ABD is congruent to triangle ACD, right? They are congruent. And now I can say angle BAD is equal to angle CAD CPCT. The reason why I'm doing this, I'll tell you now. See, I hope this is clear to you. Now guys see, we have to prove that AP is bisecting angle A, and only thing I can do here was to show that both of the angles are equal, because they will be coming handy while I prove APB and ACB congruent. Now guys see, in APB, like you guys see, we had this side common, right? We could not do anything apart from this one, but we do know that there is a property called angle side, right? I knew this whole angle, this triangle, in this triangle ABC, I knew this angle. Let's just write it here. This angle B was same as C, right? This was equal to that one, this was equal to that one, and this side was common. Or we could have done it this way also. We had proved these two equal, we could say side angle side angle also. So in triangle ABP and triangle ACP, I can see angle BAP is equal to angle CAP. That is proven. I can see AB is equal to AC. That is given. And I can see angle ABC, angle ABC is equal to angle ACB, right? ABC this and this. So you guys see angle side angle. Triangle BAP is congruent to triangle CAP. So now you can say what? You can simply say angle APB is equal to angle APC, and you can say one more thing, BP is equal to CP. You guys see both of them can be proven using CPCT. I can say this angle is equal to that one. So this implies angle APB is equal to angle APC equals to 90 each, considering you will be taking a linear pair. So you can say AP is perpendicular to BC and AP bisects BC. So this is what we had to prove. We have proved our first part, we have proved our second part, we have proved our fourth part. But this part is left because we have only showed that angle A has been bisected, but we have to show that angle D is bisected also. So for this we are going to do what? Let's erase this one. Now we are going to come to these two smaller triangles. So in triangle DBP and triangle DPC. See DBP and DPC in triangle DBP and triangle DCP, right? DCP. I can see DB is equal to DC. These two are equal. And I can see angle DBP is equal to angle DCP, that is given. That is also given. And I can see BP is equal to CP. This is proven. So you guys see side angle side, triangles are congruent, and you can simply say angle BDP is equal to angle CDP, CPCT, and you can say thus AP bisects angle A and angle D. So this is how you are going to prove this one. I hope you guys understand this. So this will be it. AP will bisect angle A and angle D. I hope you guys have understood this question, because this question is very important. Each and every question of this exercise is very important. You cannot skip any of those. So remember, they are important. You have to practice. And I will be wrapping up things here. We will be having a session for tomorrow. So do join me for that. You can always just log on to our website and have the recorded videos also, practice papers also, revision notes also. So I will be recommending you guys to download our app, get yourself registered. Till then, this is it. Practice till here as many times as you want. You have to practice each and every sum on your own, because in exam I won't be present there to teach you. You just have to remember what I've taught you there, and for that you have to practice. So I'll be wrapping up here. I'll meet you tomorrow for the next session based on this. In that session we will be covering up our remaining portion of this exercise and the remaining portion of your chapter, including a 7.4 I guess. Hopefully we will be finishing up with that, and then we will be having our doubt session. So coming week, coming portion is very important. Don't skip any class. So see you next time. Bye for now.